Welcome back. So in the previous class we have seen classification of signals. So in that we have finally saw that what is a bounded and unbounded signal. So in that I want to give one more example. You have to tell me this: e power minus 2 mod t, e power minus 2 mod t. What about this signal? Is it a bounded signal or unbounded signal? We have to check. So let's say first we have to write the signal in a more let's say easy manner. This is equal to this can be e power minus 2t for t greater than 0. That means if t value is positive, then we can say mod t is equal to t. So finally it is going to be e power minus 2t. Next, suppose if t value is negative, then mod t is going to be minus t. Then it is going to be e power 2t for t less than 0. Let's see, listen carefully what I am doing here. E power minus 2t, in general it is existing from minus infinity to plus infinity. E power 2t is also existing from minus infinity to plus infinity. But if you observe carefully, e power minus 2t only for t greater than 0. E power 2t only for t less than 0. Can I write the signal like this? E power minus 2t u of t plus e power 2t u of minus t. How you can write this, sir? See, simple thing. E power minus 2t u of t means which is existing only for positive values of time, that means t greater than 0. U of minus t means which is existing only for negative values of time. That's what the meaning of it. So finally this is the signal what we got. Now we came to know that e power minus 2t u of t is a bounded function. E power 2t u of minus t is also a bounded function. Finally the signal is bounded. If I try to draw this function, how it look like? Let's see. E power minus 2t u of t, that means exponentially decaying function which is existing only for positive values. E power 2t u of minus t, which is a growing exponential but existing only for negative values of time. That's what the signal what it look like. So if you observe carefully, is it a bounded signal or unbounded signal? Definitely it is a bounded signal because the maximum value is 1 and everything is below that. So it is a bounded signal. Bounded. In the similar manner, if I give one more example, e power 2 mod t, e power 2 mod t. So if you observe carefully, it is going to be e power 2t for t greater than 0, e power minus 2t for t less than 0. That's what it is happening. So I can write the signal as e power 2t u of t plus e power minus 2t u of minus t. That's what it is going to be. So if I draw the signal, e power 2t u of t means it is a growing exponential but only existing for positive values of time. Then can I draw like this? This is the function. E power minus 2t u of minus t means it is a decaying exponential but existing only for negative values of time. So this is how it looks like. So it is definitely going to be unbounded because at minus infinity its value is infinity. At plus infinity also its value is infinity. So it is a unbounded signal. It is a unbounded signal. I hope you understood. Okay, take it. Okay. Next classification, even and odd signals. Even and odd signals. Even signal is also called as symmetric signal. Odd signal is also called as anti-symmetric signal. Okay. When can we say a signal is even or symmetric? So the word symmetric is very important. Suppose if you take a signal, take the y-axis, whatever is there for the positive values of time, that has to be same for the negative values of time. That means the portion which is existing for positive values of time, the waveform, it has to be exact replica for the negative values of time. So whatever it is there for positive values, negative values is same. Then we can say the signal is symmetric with respect to y-axis, or we can simply call the signal is symmetric or even signal. Clear? Next, suppose anti-symmetric. So the word is anti-symmetric, unsymmetric, both are entirely different. So please keep that in mind. Anti-symmetric, unsymmetric are not same, they are entirely different. What do you mean by anti-symmetric signal? So whatever the portion for positive values of time, that has to be same for the negative values of time, but with a sign change. Then we can call that is a anti-symmetric signal or odd signal, we can say. Okay. So mathematically, how we can show this? Let's say if you take x of minus n, that means if you fold the signal, if it is symmetric, if you folding, still you are going to get the same signal. That is what the meaning of symmetric. So it has to be x of n. After folding also, you have to get the same thing. Better, let's say continuous time case, x of minus t, x of t. For a discrete time case, x of minus n is equal to x of n. So any signal is satisfying this kind of property, then we can call that signal is even signal or symmetric signal. Or symmetric signal. Okay. Next, opposite to that, x of minus t is equal to minus x of t. That means, suppose after folding, if you get the negative of the signal, then we can call this is a odd signal or anti-symmetric signal. For a discrete time case also same thing. Then it is odd signal or anti-symmetric. Anti-symmetric signal we can call. Suppose if the signal is not satisfying either of the property, that means once you fold it, it is not equal to x of t. That means it is not satisfying the symmetry property. It is not equal to minus x of t. That means it is not satisfying the anti-symmetric property also. In the similar manner, x of minus n not equal to x of n, not equal to minus x of n. So if both the things are not possible, then we can call the signal is neither even nor odd signal, neither even nor odd signal, or simply unsymmetric signal. Unsymmetric signal. So take this first signal again, even or symmetric. So we know the definition, x of minus t has to be x of t. So if this condition is satisfied, then we can call that signal is a symmetric signal or even signal. Let's see some examples. If a waveform looks like this, is it an even signal? Of course. Why? Whatever there for the positive portion of time, same thing for the negative portion of time. That means if you fold it, you are going to get the same signal. So that's the even signal. This is also even signal. Once you fold it, you can get the same kind of thing. Once you fold it, you are going to get the same signal. Suppose if I say x of t is equal to cos omega naught t. How it look like? Okay, this is how it look like. So if you see with respect to y-axis, it is symmetric. So I can say this is also even signal. Or if you replace t with minus t, if you find out x of minus t, so we know that cos theta and cos minus theta both are same. So if you replace t with minus t, again you are going to get the same kind of thing. So I can say this is also even signal. Suppose if I say delta t, so because it is existing only at y-axis, if you fold it, still you are going to get the same thing. So I can say yes, it is also even signal. I hope you understood what are the even signals means. Okay. Next, odd signals. Are anti-symmetric signals. Anti-symmetric signals. So from the definition, we know that x of minus t has to be minus x of t. Suppose if I take example like this. Is it an odd signal? Of course. If you fold it, you are going to get the negative, or whatever there is for the positive values of time, that is same for the negative values of time, but only the change is sign change. Here it is a +1, here it will become -1. I hope you understood. So this is also odd signal. Let's say -1. What kind of signal it is? It is also odd signal, because whatever there, here it is for the negative value of time also, but with a negative sign. Okay. Next, what if I take x of t is equal to sine omega naught t? X of t is equal to sine omega naught t. That means if you replace t with minus t, that is sine minus omega naught t, which is nothing but minus sine omega naught t. We know this. Sine theta, sine minus theta. Sine minus theta is equal to minus sine theta. That means if you replace t with minus t, you are going to get the negative. Or directly you can see from the graph also, waveform also is going to say the same thing. Whatever is there for the positive portion, there is a same thing for the negative portion with a negative. So here it is positive, here it is negative. Here it is negative, here it is positive. So this is a odd signal. Suppose if I take a signum t. Signum t. What about it? So whatever there for the positive portion of time, there is for the negative portion of time also. But only the change is, it is going to be minus. Plus 1 here, minus 1 here. So it is going to be odd signal. Okay. Take this example. Is 0. So remember this very important point. If x of t is odd signal, if x of t is odd signal, then x of 0 is equal to 0. X of 0 is equal to 0. Suppose, let's see, just a small proof only. Don't expect proof for everything. So for this it is a small proof, that's why I am giving. If x of t is odd, can I write x of minus t is equal to minus x of t? I can write. Now at t is equal to 0, I want to see. Then x of minus 0 is equal to 0 minus x of 0. Bring it here, that implies 2 small x of 0 is equal to 0. So 2 cannot be 0, definitely x of 0 has to be 0. That's what it is. So remember, at origin the value of the function is always 0 if it is an odd signal. That doesn't mean that, suppose every time if the signal value is equal to 0 at t equal to 0, can I say it is an odd signal? No. It is not like that. If it is an odd signal, then at t is equal to 0, its value is equal to 0. Converse is not true. Remember, converse is not true. If x of t is odd signal, then only x of 0 is equal to 0. That doesn't mean that if x of 0 is equal to 0, then the signal is odd signal. No, converse is never right. So this is the only way you have to think. See here, from Gibbs phenomena, before this value minus 1, after this value 1. So what is the average value? 0. At this value 0. At this value 0. Signum 0 is also 0. I hope you understood. Okay. So this is about the odd signal. Next, let's see neither even nor odd signal. Neither even nor odd signal. So or we can call this is unsymmetric signal. Or we can call it is unsymmetric signal. Okay. Suppose if it is not satisfying whether it is a even or odd signal, then the signal is called as neither even nor odd signal. If you take u of t, how it look like? My question, is it a even signal? No, because if you fold it, you are not going to get minus u of t. Okay. Next, if you fold it, are you getting u of t or minus u of t? Neither of them. So I can say this is a neither even nor odd signal. Or simply observe carefully. There is nothing for t less than 0. Then what you are going to compare? Means if you want to compare whether it is the same thing or same thing with a negative sign, we have to compare. But nothing is there for t less than 0. So I can simply call the signal is a neither even nor odd signal. Neither even nor odd signal. So whenever, remember, if x of any signal or if any signal is neither even nor odd, then we can write the given signal has sum of even part and odd part. Sum of even part and odd part. What do you mean by that? If x of t is neither even nor odd signal, then we can write this is a even part plus odd part. So we can decompose or we can divide the signal x of t into two parts. One is a even part and another is odd part. If you sum them, they are going to make x of t, which is neither even nor odd signal. Individually, even part is a even signal, odd part is a odd signal individually. So if we combine these two signals, we are going to get a overall signal which is nothing but neither even nor odd signal. So let's see how we can calculate this even part and odd part. Sorry, I am writing n only. This is t. This is t. Okay, listen. X of t can be written as even part plus odd part. Even part plus odd part. Suppose if I take x of minus t, what it is going to be? So if t is replaced with minus t, in a even signal, if t is replaced with minus t, still you are going to get the same thing. That means x even part of t. Next, in the odd signal, if you place t with minus t, then it is going to be minus x odd part of t. Now, observe carefully. If you sum these two equations, then these two terms will get cancelled each other. Then we are going to get x of t plus x of minus t is equal to 2 into x even part of t. So from that, I can say what is even part? That is x of t plus x of minus t divided by 2. That's what the meaning of it. Next, what is the odd part? Odd part can be calculated with x of t minus x of minus t by 2. That's what you are going to get. Okay, take it. This is the even part, this is the odd part. In the similar manner, we can write x of n if it is neither even nor odd, x even part of n, x odd part of n. So here also even part of n is equal to x of n plus x of minus n divided by 2. In the similar way, odd part in the discrete time case is x of n minus x of minus n divided by 2. Okay, take it. Just now we came to know that, example I am taking. Let's take a signal x of t is equal to u of t. So just now we came to know that u of t is a neither even nor odd signal. Then can you tell me what is the even part and odd part in it? Neither even nor odd. So can you tell me what is the even part and what is the odd part? So just now let's see. So to find, let's say this is going to be how it look like. We require x of minus t, that is u of minus t. How it look like? Next, x even part, that is x of t plus x of minus t by 2. That means we have to add these two signals and divide it by 2. Before 0 its value is 0, before 0 its value is 1. 0 plus 1, 1 by 2, that is 1 by 2. 1 plus 0 by 2, that is 1 by 2. So finally we are going to get a signal which is like this. Whose value is equal to 1 by 2. So is it an even function? Yes. If you fold it, you are going to get the same thing. So it is an even signal. Next, odd part of the signal, that is x of t minus x of minus t divided by 2. We have to subtract it from this signal and divide it by 2. 0 minus 1 divided by 2 minus 1 by 2 minus 1 by 2. After 0, 1 minus 0, that is 1 by 2, that is 1 by 2. Yes, this is also odd signal. Okay. Now I have a doubt. If I add them, can I get the original signal? Yes. Let's say before 0, 1 by 2 minus 1 by 2, if I add them, you are going to get 0. Yes. After 0, 1 by 2 plus 1 by 2, we are going to get 1. So from this, can I conclude that yes, this is the even part, this is the odd part of the x of t, which is u of t. So we can write from here, we can say u of t is a neither even nor odd signal, and it is having even part which is 1 by 2 plus it is having odd part which is nothing but 1 by 2. Can I write the function is signum t? Because signum t means it is 1 and minus 1, but if it is 1 by 2 signum t means it has to be half and minus half. So this is going to be 1 by 2 signum t. By 2 signum t. So this is the even part, this is the odd part. Okay, take it. We are seeing at this level, just I am deviating a little bit, just a little bit deviation. Let's see what we can do. Some more information I want to pour on you. Listen carefully. Some extra information, it is not related to this one because we are at the junction. If I say u of t plus u of minus t, what it is going to be? Its value is 1. How, sir? Let's say u of t, how it look like? This is how it look like, whose value is equal to 1. U of minus t, that means existing only for negative values of time. That's what this is. If I add them, so if I add them, what is the result we are going to get? Which is 0 plus 1, 1, 1 plus 0, again 1. So this is what the signal we are going to get, which is 1. The function value is equal to 1. So u of t plus u of minus t, whenever you see, that is going to be 1. Okay. Next. What if I take u of t minus u of minus t? What it is going to be? If I subtract it, 0 minus 1 minus 1, 1 minus 0, 1. So before 0, it is going to be minus 1. After 0, it is going to be plus 1. What is this function? For t less than 0, its value is minus 1. For t greater than 0, its value is 1, which is nothing but signum function, signum t. So this is a signum function. Signum function. So signum function can also be written as signum t is equal to, this is a 2u of t minus 1. 2u of t minus 1 also we can write. How, sir? Listen. Two u of t, how it look like? Whose value is equal to 2. 1. 1 means for all the values of time, its value is 1. That's what it is. If you subtract it, 2u of t minus 1, what is the result we are going to get? Before 0, 0 minus 1 minus 1. After 0, 2 minus 1, 1. So this is also a signum function. So signum function can be represented in two ways, u of t minus u of minus t, or 2u of t minus 1. Okay, take them. Some more extra information. In the discrete time case, if I take u of n plus u of minus n, what is going to result? Let's say u of n, how it look like? For all the values of n, 0, 1, 2, 1, 1, and so on. This is what u of n. U of minus n, simply folding it at 0, 1, minus 1, minus 2, and so on. If we add them, what is the result we are going to get? So if we add them, so everywhere up to minus 1, 1 plus 0, 1 plus 0, so it is going to be 1. After 0, 1 plus 0, 1 plus 0, everything is 1 only. But except at 0, we are having 1 plus 1, which is nothing but 2. So how it look like? At 0, its value is 2. And for remaining values, its value is 1. And so on. Here also. So this is what the signal, which is not equal to 1. What exactly is equal to? So up to this 1 plus some 1 is there, 0, we have to add 1. So 0, 1, what is that? At 0 we are having 1. What is that? It is going to be delta n. So this function can be written as 1 plus delta n. 1 means everywhere its value is 1, but at 0 we are having 1 more. So that is given in the form of delta n. So this is nothing but 1 plus delta n, which is not equal to 1. Remember. But what if I take u of n plus u of minus n minus 1, u of n plus u of minus n minus 1. This value is going to be 1. How, sir? Let's say u of n, again I am drawing it. U of n, u of minus n minus 1, that means it is existing only up to minus 1. At 0 its value is 0. If I add them, let's say up to minus 1, 1 plus 0, 1 plus 0, like that. At 0, 1 plus 0, again 1. At 1 also 1 plus 0, 1 plus 0, like that. So finally, if you add them, the result is nothing but simply for every value of n, its value is 1. So this is what we are going to get, 1.